Hey guys, welcome to this video on distributions of sample means. In the previous video we looked at sampling distributions. Now we're going to expand on that just a little bit and look at sample means. So, as well as studying the sum of n number of observations of a random variable, we can also consider the mean of those observations. So if we were looking at, let's go to the same example that I used last time, the number of peaches in a can. If we add all of those weights up together and divide it by how many there are, we have the mean. And it's the same way that we calculate the average for everything else. So for n independent observations of a random variable, the mean of the observations is the random variable xn with a line across the top of it. And this is just adding all those values of x together and dividing it by how many there are, like I said with the peaches example just previously. We also know that the x1 plus x2 all the way up to xn is in fact our sampling distribution, and we could write that as Sn, much like we have been doing. So we could actually rewrite this xn, or our sample mean, as being equal to 1 over n multiplied by our sampling distribution, which is the same as our sampling distribution over n. Either way is acceptable. Pick one. So that's the means of it. Let's also look at the standard distribution. If the random variable x has a mean and a standard deviation, then the distribution of sample means has the mean being exactly the same, and the standard deviation divided by the number of samples that were taken, or the square root of that. Let's look at an example here. So what I want you guys to do, I just want you to pause the video, get this written down. Once you've got that written down, continue, and we'll see you in half a moment. Alright, you should have got that written down. If you don't, please go back and get it written down. So in this example that we're going to go through here, the life expectancy, which I'm going to call x, so x is our life expectancy of a certain brand of battery is known to have a mean of 27 hours. And a standard deviation being equal to 3.25 hours. Batteries are sold in packets of 6, so let the random variable x6 be the mean life expectancy of the batteries in a packet. So now, if the batteries in the packet were tested and the number of their hours they lasted were as follows. So we've got 25.3, 21.6, 27.75, 22.25, 35.5, and 28.5. So we've got 6 batteries there. That's how long each of them lasted. So what is the corresponding observed value of the random variable x6, which is just our mean life expectancy? Well, to do this, what we're going to do is add all of these values up and divide it by 6. We're going to find the average of all the values that were found. And if you plug these numbers into your calculator, you'll find that it's going to be roughly equal to 26.8 hours. That's our mean of the sample that we've taken. What we're going to do now is, what is the mean and standard deviation of our sample of 6? That's our observed value. Now we want to work out what is the mean of it. So the mean of 6 is just equal to the mean of x, which in this case we were told is 27 hours. Now you can see that our observed is different to the mean of what was actually found over the largest sample, and that's perfectly acceptable. If we're finding that the mean of our sample, in this case that was our 26.8 hours, if we're finding that that is well different to our actual mean that we're told, in this case 27 hours, then some questions have to be asked to the manufacturer of the battery that they might be just fudging their results, especially if our observed is significantly lower. So, thing to remember, that this is your observed. This here is stated. The final bit is working out the standard deviation. Well, we're told that standard deviation is just going to be the standard deviation that we're given, which is 3.25, divided by the square root of how many we're taking, in this case 6, which we know is, if you plug that into a calculator, roughly equal to 1.33 hours. Now, if you remember looking at your normal distribution, that within a standard distribution either side, it's roughly 68% of the data, or you expect 68% of everything to lie within that range. And you can see that our observed of 26.8 hours does in fact lie within that. So in this case, even though we're missing out on 0.2 of an hour, which is equivalent to 12 minutes, that it's really not that far off. So that's it for this video on distribution of sampling means. So just got to remember that what we find when we add them all up and divide it by the number is our observed value. The mean is the stated value. So that's the two big things to take away from this video. If you've got any questions, please ask. As always, thanks for watching, and we'll see you next time.